All right, so what's the minimum number of things you need to know in order to find everything about that triangle? Anybody know? You want to take a guess? Who thinks they need to know one other thing besides this right angle to find everything about that triangle? Just one other? Okay, what about two other things? Who thinks two other things? Two other things. What about three other things? Who thinks three other? Four? Five? Five other? Six? Okay. Now in the worksheet we just handed in, the last one where it was 7 and 8, where it said solve the triangle. How many things were you given? Two and the right angle, right?
Yeah.
You're given one angle and one side. So how many things besides the right angle do we need to know here? Two more. Okay. We can solve any triangle, any right triangle, if we know two other things besides that right angle. Okay. So in order to solve this, we need to know one other side and one other angle. Does that make sense? All right. Today we're gonna learn how we can do word problems with trigonometry. All right. In these word problems, they won't draw you the picture. Okay. You have to draw the picture for yourself. Okay? Now, some very important terminology in these word problems are things called angle of elevation and angle of depression. You may have heard these words before. Okay. But we're gonna go through and talk about how it relates to trigonometry. All right. So there isn't really much to learn new today, but there's constant applications of trigonometry that we're going to learn today. All right. Angle of elevation. What does the word elevation mean?
Rising.
What? Rising from where?
Ground.
From the ground, right? Elevation is rising from the ground, right? So the angle of elevation is the acute angle between someone's line of sight. The acute angle between someone's line of sight and the horizontal when they're looking up at an object. Right? So the angle of elevation is an acute. What does acute mean again?
Acute.
The lower than 90, right? Right, so 90 is bigger. An acute angle going on. That's my sentence up. Okay. An acute angle between the line of sight and the horizon when looking up at an object. So the angle of elevation is an acute angle between the line of sight and the horizon when looking up at something. So didn't have time to draw all 50 stars and all 13 stripes, but there's our person, and there's the flag. Okay. Now this person is going to look at the flag, right? When this person looks at the flag, are they going to look up or look down? Look up, right? So their line of sight will look like that, won't it? Right? Because they're looking up at the flag. Now the horizon, right? When we look out at the sun set's behind the horizon, right? Right? The horizon is parallel to what? The ground, right? So when we're talking about the angle between their line of sight and the horizon, it's the angle between this blue dashed line and a line that's parallel to the ground. And that should be perpendicular to the flagpole, assuming the person put the flagpole correctly. Right? Does that make sense? So this black line represents the horizon. The dashed blue line was the line of sight. Right? Now the angle of elevation, that's the thing we're talking about here. Right? I'm going to number two angles here. I want you to think, based on the definition, which angle is our angle of elevation? Now don't shout it out, just think to yourself for a moment. Which angle is the angle of elevation? Angle 1 or angle 2? Think to yourself about it. Okay, read the definition if you need to. So it's an acute angle between the line of sight and the horizon when looking up at an object. So, raise your hand if you think you know. Which one? What do you think it is, John?
1.
Angle 1. Good. It is angle 1. Okay. Angle 1 is made between the horizon, right, the horizontal line, and the line of sight. So this angle right here, that angle right there, is our angle of elevation. That angle is our angle of elevation. Does that make sense? Yeah. Just by telling me it's an angle of elevation, that makes it very easy for me to draw the picture. I know my horizon is going to be on the bottom, my line of sight will be the hypotenuse going up, and then my third side will be whatever it is I'm looking at. That makes it kind of easy to draw the picture. Now, angle depression. This one doesn't stick out as much. I know now depression kind of has a psychological connotation to it, but depression used to mean decreasing, right? So when we're talking about angle depression, instead of looking up, how do you think we're looking? We're looking down. Okay. So the angle of depression is basically the same thing as angle of elevation, but instead of looking up right here, it should be looking down. So it's an acute angle between the line of sight and the horizon when looking down. Oops, that's and, not at. At and.
Why is it angle depression? Like angle descending?
Another book on geometry calls it angle of descent. So, but angle of descent implies movement, whereas we might not necessarily be moving. Like an airplane has an angle of descent when it lands. Someone looking down has an angle of depression because they're not actually moving down. So here I have someone sitting on a hill where their golf ball is sitting. Okay, looking down at a green. Right? So their line of sight from the person to the hole. Right? We'll draw in the blue again. It's going to look like that. Right? There's the line of sight. Right? Yeah. Now, whenever people draw triangles with angles of depression in them, for whatever reason, they like to draw it where the horizontal is down here and the vertical is right there, because people like to think that the triangle is resting on the table, right?
Right.
Right? People are comfortable drawing triangles like this, aren't we?
Yes.
If I told you to draw a triangle, it'd probably look like this. Okay? If you draw triangles for angle depression that look like this, they are incorrect. Okay? If you draw your triangle like this, it will mess up your trig ratios. Okay? The side opposite and the side adjacent will be switched in this case. Right? The correct way to draw this, because it says in the definition, it's the angle between the line of sight and the horizon, right?
Yes.
The way I drew it, here's my line of sight. Is this the horizon? No, that's a vertical, isn't it?
Yeah.
So that's not the correct line, right? It needs to be between the line of sight and the horizon. So my horizontal line needs to be right there. So that means theta right here. This is my angle of depression. And the vertical, finish my triangle down there. And this should be a right angle because it's between the horizontal and the vertical. All right, does that make sense? Are there any questions? Any questions? No questions? Okay. Basically, angle of elevation, angle of depression, they're terms that they'll use in word problems when describing triangles. So those are things that we just need to know, so that way we can solve a word problem in trigonometry and draw ourselves a picture. All right. Now I passed out a worksheet for you guys. It looks like this. Okay, it's a collection of word problems that I've written. So if there is any spelling or grammar errors, I'm sorry. I teach math for a reason, right? Okay. All right. First one, number one, and I want you to think to yourself as you work through this. Identify the angles of elevation and depression in each triangle below. Put an E by the angles of elevation and a D by the angles of depression. All right. So in each triangle below, identify the angles of elevation and angles of depression. Put an E by the angles of elevation and a D by the angles of depression.
Turn them off, please.
I will. I'll set the camera so I'll pick it up. You guys see all right with the lights off?
Yeah.
Yeah.
I like it. Oh, you have an eraser?
Yes, I do.
Let's see. I think I did it right.
I did.
I'll just give it to
All right, so number one, first triangle. What do you guys think? Will this have an angle of elevation or angle of depression? Depression? Elevation? Okay.
It's
Hopefully,
elevation.
you drew the pictures we drew in our notes. This one looks more like the person looking up at the flagpole, doesn't it?
Yeah.
Yeah. So this will be an angle of elevation problem. Now, which one's going to be an angle of elevation? The one on top or the one on the right?
One on the right.
One on the right. This is my angle of elevation. Now, could this be my angle of depression?
Yeah, no.
No. Okay. Because angles of depression are with the horizon, right? Horizon means the horizontal line. So the angle of depression would be up here. Okay, does that make sense? So can I have elevation and depression in the same triangle? No. Because both of them are made with the horizontal line. Right? Elevation's made with the horizon, depression's made with the horizon. Right? So you can't have them both in the same triangle. Okay? So, depression or elevation? Depression. Bottom angle or top angle?
Top.
Top angle. That one's the right angle.
Elevation.
Elevation, where's the angle?
On the left.
On the left. Okay, that's a funny looking.
Depression.
Elevation.
Depression.
Depression.
Okay. Think here's my horizontal, right? Right, I started my horizontal,
No, I said.
and then I look down.
Why you say my
Okay, then John, I started the horizontal,
I said.
and I look down. Alright?
I'm up here saying depression. He's up here playing high.
Alright, so a way we can tell a difference. Alright? In the triangle, find the horizontal. Okay, so like in this triangle, here's my horizontal. To make my angle, I'm moving downwards. Right? So it's like I'm staying here and I'm looking down at something. Right? Right? You guys see that? To make the elevation, I start the horizontal and I look up. Okay? Look up. You see that? Yeah. Okay. All right. Any questions about number one? Questions about number one? Oop, what did I just delete? Don't close it down now. Please don't close it. Sorry, it'll come back up. All right. Number two. A 3-foot tall child is standing 10 feet from the base of a tall tree. While looking up with an angle of elevation of 71 degrees, the child sees the top of the tree. How tall is the tree? Okay. Using the ideas of angle of elevation, we can draw ourselves a triangle for the situation. All right. So I have a child. Here's my child. Okay. Here is my very artistic drawing of a tree. You guys like that? Nice drawing, huh?
It's like a lot of.
No.
I can't draw. I can draw a better tree.
I'm not an artist.
He's a math teacher.
That looks like a.
He's a math teacher.
Hey, it's a tree then. You saw it.
It looks like
So there's my tree. Now it says the child looks up at the tree with an angle of elevation of 71 degrees, right? Okay. So what I like to do is I like to draw the line of sight now. So here's the child looking up at the top of the tree, right? And if it's making an elevation, an angle of elevation, is my horizontal line down here coming from the child, or up here coming from the tree? Comes from the child, right? Because it says it's an angle of elevation. That means we were looking horizontally, right? And then we looked up. Now this should be a right triangle, assuming the tree is growing straight. Okay. The wind didn't take it out when it was a young tree. Okay, we're assuming the tree's growing straight.
You never know.
You don't. I mean, sometimes it's different. All right. Now, where's the 71-degree angle? Is it by the child or by the tree? By the child. So our 71-degree angle is down here. Right? All right. So we got a good start to our picture. And number 2, a 3-foot tall child is staying 10 feet from the base of the tall tree.
10 foot is the.
So, where's 10 foot?
10 foot's on the bottom, the darker.
This one?
Yes.
Okay, good. This one is 10 feet. Now, does the 3 feet matter?
Not really.
You sure?
Yeah, I'm pretty sure.
The 3 feet does matter. And when we come to the end, I'll show you why.
Of course.
The child is 3 feet tall, right? We're assuming when the child's looking up that the child's eyes are at the top of the child's head. Okay. So the child's 3 feet tall. Now, how tall is the tree?
3 foot.
So if I'm looking at my triangle, where's the height of the tree? Is it my hypotenuse? Or is it the green line? The green line, right? The whole green line is the height of the tree, isn't it? Yeah? Okay, we want to find this, don't we?
What does that say on that
Why is
document?
that 10 feet the horizontal?
Because it says the child is 10 feet from the base of the tall tree.
Base is the bottom.
Yeah.
I didn't see
So, we want to find x. What's your question here?
Where does that say on the little dotted line?
This one?
No, above that. Above. No. Oh, is that just a smudge?
It's the arrow.
The arrow. The arrow from the computer.
Oh!
That's
I can see that.
Okay, it's gone now. Alright. Now, 10 feet. What is that to my angle? Is it opposite, adjacent, or hypotenuse?
It's adjacent to J.
Good. 10 feet is adjacent, right? Right? X is what, Matt? Opposite. So I got to use the part of SOHCAHTOA that has the opposite and the adjacent, has the O and the A. Right? So which part of SOHCAHTOA has the O and the A?
The tan.
Tan. Good.
I didn't have to look.
There's nothing up there.
I wrote it over here because it got erased when I cleaned the board this weekend. So tan of 71 equals opposite, which is
X
x
over 10.
over adjacent, which is 10. Good.
And then you
Then you
you want to explain? Alright, you divide and
Oh, where do I? Hold on a sec.
what?
Come on.
Hold on a sec. We'll get to
What's
it.
that?
Okay, I'll let you tell me what to do next. All right. Just think about it.
Alright.
All right. Tan of 71. What do we do? What's tan of 71? 2.9. Okay.
Touch.
If you got -3, I think that means you're not in degrees. You need to change the radians. Okay. Now, Josh, we're dividing by 10. So how do I get rid of the 10?
Divided by 7.
Nope. It's already divided, so we have to
Time.
multiply.
That's what I said.
Okay.
Really?
I do it a different way.
All right. So now we know how to move the 10 over. Okay. So that means x equals 10 times 2.9. So what does x equal? 29. So 29 is x, right? Now if I look back at my pictures, x the whole tree?
No.
No. X is just the part that's taller than the kid, right?
Yeah. We still
Right.
have to find a hypotenuse.
No, we don't find the hypotenuse. We just gotta find the height of the tree. Josh, pay attention, please. Okay. The kid is 3 feet tall, right? So that means this tells us the tree is 29 feet taller than the kid. So to find the whole height of the tree, what do we do, Matt? Add a 3 to the 29. So then our whole height of the tree is 29 plus 3, which is
32.
32. So the tree is 32 feet tall. Does that make sense? Biggest mistake students make in a problem like this is they forget to add the 3. Okay? They find that height, they find that x, and they're happy, they think they're done, they move on. Okay? It's an easy mistake to make. Okay? But on tests, that'll be worth a point at least. Okay? So to get your full credit, you got to make sure you have that 3 in there. Okay? So don't forget about that. Don't forget about that 3. Right? All right, any questions? Am I done talking? No. No, I'm not done talking. All right. And it closed on me.
What are you doing?
So I think you should just be done for the day.
I'm not going to be done for the day. Don't worry, Matt. Do not worry, friends. It'll come back. Look at that. Oh, come on.
What happened? Why did you close on me?
Because.
Does it not like you?
Because it's telling Branch that he needs to be quiet.
But you guys have number 3 already. We can just do it together. Ah, there it is.
No one, I was saying,
Matt, fear not. It has been restored. Okay, so we did number 2.
Wow.
I'm not annoying. I just worry about your grades. All right. What's up there for? Okay, number 3. An airplane is flying 3,000 feet at 3,000 feet when it decides, or when it begins its descent. If the airplane begins landing by flying with an angle depression of 15 degrees, how far away is the airport? Okay. Like I said before, drawing the picture is how we're going to figure this problem out. Okay. It's incredibly difficult to do these problems without drawing a picture. Now, if you're a good artist, it's easy to get distracted. So, if you enjoy drawing pictures, that's okay. I'm not a very good artist, so I draw stick pictures.
I think you're really good. Just kidding, that shit.
There's my stick airplane. You guys like that?
No.
Pretty proud of it. Okay. Got a runway which has dotted lines in the middle, which I don't understand why, because there's never two-way traffic going on a runway.
So they can
Good.
see it
I
from
would
above.
say it
How does it-
Probably a good idea.
I say no, it gives him the place to get the wheels.
Oh, so I try to land in the center.
Yeah.
I gotcha. That makes sense. All right. So an airplane is flying at 30,000 feet when it begins its descent to land. If the airplane begins landing by flying with an angle depression of 15 degrees, how far away is the airport? So, angle depression.
Please excuse interruption at this time. All seniors, please report to the auditorium. Again, all seniors, please report to the auditorium at this time for a senior meeting.
So,
I
that's
have to go.
the blue line is my line of sight. Seniors, not sophomores. Blue line is my line of sight, right?
I am a senior.
Right?
Yeah.
Now, the angle depression is made. The angle depression, is it made with a vertical or a horizontal? Horizontal. Okay. So, in order to draw this triangle correctly, that means my 15-degree angle has to be right there. Right? That's my 15-degree angle. Right? And then here is my height. Now, hopefully my vertical, my horizontal, and my perpendicular make a right angle. Sorry, my triangle's kind of small. Everybody sure the 15-degree angle is? No? Between my line of sight and the horizontal? Okay. Now, it says the plane is 30,000 feet, flying at 30,000 feet, right? Is that 30,000 feet a height or a distance? Height. Okay. So, is it a vertical line or a horizontal line? Vertical line. So this right here, this line here, this is where the 30,000 feet is. Okay. Now, if you draw your triangle incorrectly so that the horizontal is on the bottom, right, then the 30,000 feet will be adjacent to your angle, right, and it'll change our ratios. Because right now, the 30,000 feet is opposite, right? So if we draw our triangle incorrectly, then the 30,000 feet would be in the wrong spot in the triangle, making our answer incorrect. So we gotta make sure we draw the correct triangle. Okay. Now, I want to know how far I am away from the airport. So am I trying to find the adjacent side or the hypotenuse? The adjacent side. Okay. The adjacent side. I know it can be difficult to determine which one they want. If they said how far does the plane have to fly, then that'd be the hypotenuse because they have to go down the hypotenuse to get to the airport. Okay. But how far it is away would be the x. All right. Now, what should I use to find my x? We know opposite. We want to find adjacent, right? So which one should we use again? Tan. Okay. A lot of the word problems end up using tangent. Right? It just seems, for whatever reason, it's easier to write a problem that involves tangent than it is to write one that involves so sine or cosine. So tan of 15 equals opposite 30,000 over adjacent x.
Okay, we get the point.
What's tan of 15? What is it? 0.27. That's it? Yeah. It's like 0.268 something. Okay. So 0.27 equals 30,000 over x. Now how do I solve for x?
Okay, times x.
Multiply by x. Whenever x is on the bottom, we multiply by x, right? Okay. So multiply by x.
And divide by
These cross out and run out of room, so I'll do it over here. 0.27x equals 30,000.
divide 0.27 by 30,000.
Divide both sides by 0.27, like John said. We get x equals
Something.
111,000. 111.11. Wow, it's pretty redundant there, huh?
No, not.
That's a lot of feet, isn't it? Yeah, does anybody know how many miles that is? Divided by 5,280, right?
Yes. It's from physical science. I don't remember that from physical science.
So I got 21 miles. When I divide by 5,280, 21 miles. Think the pilot can see the airport from there? They might be able to see the airport, but I think they can see if there's anything else on the runway?
No.
No, so they gotta make sure they're communicating with that air traffic controller, right? Very important job. Okay. All right. Any questions about number 3? Any questions about number 3?
No.
Yes, no? All right. Number 4, I want you to read that, and then we're gonna draw. I want you to start drawing the picture, and we'll draw one together here in a second. All right. So number 4, I want you to read the problem, and then draw the picture, and we'll draw it together here in a second. So a 15-foot tall ladder is leaning against a house with a 68-degree angle of elevation. How far away is the base of the ladder from the house? So try drawing that picture. The most difficult part, I think, about these problems is drawing the picture. You can draw the picture, and it's just like a problem we did on Friday.
We just solve it if you wanted to.
You want to?
You say it.
You want to? I was busy doodling. I'm sorry.
Don't forget the chimney.
Good idea.
Houses don't have chimneys.
Can you turn around?
It's either a chimney or it's a little toilet pipe that sticks out, right?
No.
Just a chimney. Okay.
What?
I like having windows in the attic.
Yeah. That's what.
All right, so here's my house, right? My flowers are a lot better than last hour. Last hour they looked like spiders. So here's our house. Now where's my ladder going to be?
Left.
Now is the ladder going to be a horizontal line, a vertical line, or kind of like a hypotenuse?
Hypotenuse.
It's going to be a hypotenuse, isn't it? Because ladders that are horizontal don't really get you any higher, right? Right. Ladders that are vertical aren't safe to climb, right? So you lean back when they fall. Okay. So your ladder is always going to be hypotenuse. Anytime you have a ladder problem, the ladder will be the hypotenuse. Now, how long is our ladder?
15 foot tall.
It's a 15. Okay. When they say a 15-foot tall ladder, that doesn't mean that it reaches 15 feet. That means the length is 15 feet. That means the ladder is only 15 feet in length. Something to keep in mind if you're ever buying a ladder. Just because it's a 15-foot tall ladder, it's not going to reach a 15-foot roof. Okay. If it does, it won't be safe. All right. So 15 feet is my ladder. Now, it says the angle of elevation is 68 degrees. Now, is that 68 degrees up by the roof or down by the ground? Down by the ground, right? Because the angle of elevation is looking up, isn't it? Right? So it's like I start here, I have to look up to see the roof. So this is my 68 degrees. And we want to know how far away the ladder is from the house. right? So am I trying to find the vertical line or the horizontal line?
Vertical.
How far it's away from the house, right?
Oh, horizontal.
Horizontal. If they want to know this, they'd ask how far up the house can the ladder reach? Or how high can the swim climb ladder get to? Okay. So I want to find x. All right, does that make sense? Yeah? All right, so try to find that on your own.